All right, last section of notes for chapter 1 is over 1.6, midpoint and distance in the coordinate plane. The two objectives are to develop and apply the formula for midpoint and use the distance formula in the Pythagorean theorem to find the distance between 2 points. Here's going to be our vocabulary that we're going to learn. Coordinate plane, leg. First one, coordinate plane. It's basically the plane that is divided into 4 regions by an x and a y axis. You all have seen this before. Here's the y-axis, this is the x-axis. This point would be 3, 2, something like that. This is a coordinate plane. The whole thing, that's what a coordinate plane is called. So you're going to have a y-axis is the vertical, x-axis is the horizontal. Whenever you're given a point, you're going to use the x, y. This is how our answers are going to be if we're given a coordinate point. So our first buzzword is this xy, parenthesis x, comma, y, parenthesis. This is a location or a coordinate of a point. Okay, you can find the midpoint of a segment by using the coordinates of its endpoints. Calculate the average of the x coordinates and the average of the y coordinates of the endpoint. So that's what the midpoint formula is getting ready to show us. So go ahead and, once I get done explaining this, pause the video and write this down. I'm not really worried about having this written down as much because we'll see an example here in a minute. But the midpoint of M of AB. So this line is AB, and M is the midpoint. So x1, y1 is point A, x2, y2 is point B. This right here, this is the formula that you're going to use. This M is the midpoint right here. This is how you find M. You take the x1 and you take the x2, you add them together and divide by 2. Then you take the y value of both, add them up and divide by 2. So what you're doing is you're finding just the average of the 2 points. So if I think about the distance of x's, so here's my distance x to x. Here's x1 and here's x2. The distance between them right here, that's the midpoint. I found the averages. So if this is 1 and this is 3, I add them together and I get 4. Divided by 2, I get 2. So the midpoint of 1 and 3 is 2. Now if I look over here, the midpoint of x2 or y1 and y2 is going to be right here. So this is the average of the y's, this is the average of the x. So those two as a coordinate pair is the midpoint. So to make it easier, picture the problem, plot the segment's endpoints on a coordinate plane. So as we're starting doing this, we're going to plot these coordinates on a grid. And it's going to help us kind of see where the midpoint is going to be a little bit. All right, so example 1, find the coordinates of the midpoint of PQ with the endpoints P and the endpoints Q. So this is going to be Q up here, and this is going to be P. So the formula for a midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. So what I'm going to do, since they give me this one first, P, I'm going to say this is point 1 and this is point 2. So my x1, so P is point 1. So negative 8 is going to be x1. And 3 is going to be y1. This is the x and y of the first point. So Q is point 2. So x2 and y2 are going to be the x and y values of this one. So negative 2 is going to be x2 and 7 is going to be y2. Now to find the midpoint, I just plug these 4 numbers, negative 8, 3, negative 2, and 7, into this formula. So the midpoint is going to equal, I look for my x1 value. x1 right here is negative 8. So I put in negative 8. Then I'm going to add x2 value. x2 right here is negative 2. I'm going to divide by 2. This is getting kind of in the way, so I'll have to rewrite this somewhere. Okay, so down here I'm going to do, this is x, we'll call this xm for midpoint. Since I'm running out of room, I'm going to do ym down here. Ym is going to be y1, which is 3, plus y2, which is 7, divided by 2. So let me go ahead and shrink this down, and I'll rewrite this all as 1. So m equals -8 plus -2 over 2, comma, 3 plus 7 over 2. So this is the x1, x2 divided by 2, y1 plus y2 divided by 2. Okay, now I'm going to solve for this. -8 plus -2, same signs, add and keep. So -10 over 2. 3 plus 7 is 10 over 2. So when I reduce these, m equals -5, +5. So now the benefit of putting these on a coordinate grid is we can now go back and look at -5, 5. So here's -5, you go on your x first, up 5. Right here is what we're saying our midpoint is, and that looks to be about right. So that's the benefit of plotting these, is that you can get a better idea of if you're doing it correctly. If I would have said my midpoint is -2, 0, -2, 0 is right here. That would make no sense at all to say that's our midpoint of this line that's way up here. So the benefit of plotting these out, as we're getting going, we're going to plot all of our lines out and then find the midpoint. All right, so this one is going to be a little more difficult. They're going to give you the midpoint and one of the coordinates and ask you to find the other coordinate. So they've got the midpoint is here and the x coordinates are here. I'm going to call this x coordinates our point 1. So x1, y1 is going to be 2, 7. Our xm, ym, which stands for midpoint, is 6, 1. Now our x2, y2 is what we're figuring out. Okay? So now I'm going to put this, I'm going to use these sets of points and put them into my midpoint formula. So I've got midpoint formula is xm, ym equals x1 plus x2 over 2 y1 plus y2 over 2. So now I just put in what I know. xm, ym is 6, 1. So I'm going to put 6, 1 over here. And I'm going to set this equal to x1 was 2. I don't know x2, so I'm going to leave this as x2 over 2. Then I've got y1 is 7 plus y2 over 2. Okay, so now I've got this set up. So now I need to find my x2, y2. So what I have to do is I take, this is my x information, and this is y information. So likewise over here, this comma separates the x between the y. So I'm going to take my x information and set it equal to my x information. I'm going to circle my x's. Then I'm going to take my y information and set it equal to my y information. So let me do my x's first. So I set 6 equal to 2 plus x2 over 2. So I've taken my x information and set it equal to the x information. Now I'm just solving for x. I multiply both sides by 2 because I'm dividing by 2. So that cancels this out, and I get 12 equals 2 plus x2. I'm going to subtract 2 from both sides. I get 10 equals x2. So my x2 value up here in this x2, y2, that first question mark is going to be a 10. Okay, now I'm going to take my y information and set it equal to the y information over here. So I'm going to take 1 equal to 7 plus y2 over 2. So same as I did over here, I'm going to multiply my 2 across on both sides to cancel these out. So I get 2 equals 7 plus y2. To get y2 alone, I subtract 7. I get negative 5 equals y2. So this value up here is negative 5. So this answer, this is our x2, y2. So this is the point of y. This is the coordinates of y. So then if I took this back and I said this is y and this is x, if I found the midpoint of x and y, I should get 6, 1. Okay, so the ruler postulate is what we can use to find the distance between 2 points on a number line. The distance formula is used to calculate the distance between 2 points in a coordinate plane. So in our xy plane, we've got distance like this. I can find the distance from this point to this point. And I'm going to use this formula. So please make sure you have this formula written down. And your second buzzword is formula. So in your notes, make sure you have D equals square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's put this into an example. Example 3, using the distance formula, they want us to find FG and JK. Then determine whether FG is congruent to JK. So first, I'm going to find the distance of FG. So distance of FG. I use my square root. I'm going to have x2 minus x1 squared plus y2 minus y1 squared. So let's see what x2 and y2 is. Since I'm using FG, I'm going to use these points. So F is going to be the point 1, 2. G is going to be the point 5, 5. If I look at my coordinate grid, I go over 1. I went over 1, up 2. Over here I went over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. So F is 1, 2, G is 5, 5. I'm going to go ahead and call this point 1 and this point 2 just because FG is written as 1, 2. It's just going to be easier to think about this. So my formula tells me to do x2 minus x1. So my x2 value is the x value of point 2. So I take 5 and I put it in this spot. And I'm subtract the x2 value. Subtract the x1 value. So I go to the 1, and I find the x value is 1, so I subtract 1. Now for over on the y's, I'm going to take y2. So I'm going to take the y value of 0.2, and I'm going to subtract the y value of 0.1. So when you do a little math, you get 5 minus 1 is 4. You're going to square that, and you're going to add that to 5 minus 2 is 3. Square that. So this now becomes 16 plus 9, which is the square root of 25, which equals 5. So the distance of FG is 5. Now I'm going to find the distance of JK. So distance JK equals, again, I'm going to use my square root. This is going to be some x2 minus x1 squared plus y2 minus y1 squared. So now I'm going to enlarge my graph again. I'm looking at J. J is the point over 1, 2, 3, 4 to the left, so negative 4. And I go up 0. And now for K, I go over 1 and down 3. So over 1, down 3. Okay, so now I'm just going to use my points again. Again, I'm going to go ahead and use, since they give it to me as JK, I'm going to do J is 0.1, K is 0.2. This will work, this distance formula will work even if you chose J to be 0.2. So it does not matter which one you choose to be 0.1 or 0.2, as long as you keep your X and Y the same. So if you're going to call K 0.2, make sure you use -1 and -3 as your 0.2. So again, now I'm just going to go in and substitute everything. This calls for my X2 spot. X2 is going to be -1. And I'm going to subtract the X value of 0.1 is -4. Over here, I'm going to take the Y value of 0.2, which is -3. And I'm going to subtract the Y value of 0.1. So when I combine these, I get -1 minus -4. So change this to minus and negative is plus. -1 plus 4 is 3. Square that still. Add -3 minus 0 is -3, and I'm going to square this. So I get 3 squared is 9. -3 squared is also 9. So this becomes square root of 18. I already know this is not going to give me 5, so they're not going to be congruent. But let me go ahead and reduce my radical, so we're getting in the habit of that. I need to find, to reduce a radical, I need to find the perfect squares in 18 that will come out to be a perfect square. So I know 9 is a perfect square. 9 times 2 will give me back to 18. This becomes 3, and this becomes root 2. This is Algebra 1 stuff. We should all be able to do this. If not, make sure you either come in or ask other questions on how to reduce your radicals. So this is my answer for the distance of JK, and this was my answer for the distance of FG. 3 square root of 2 does not equal 5, so they are not congruent. So this was a lot of work just for one problem, but it's going to get easier later on. So 5 was the distance for FG. 3 square root of 2 was the distance for JK. Those two are not congruent. All right, you can also use the Pythagorean theorem. You guys have seen this before in either Algebra 1 or Algebra Half. You can use the Pythagorean theorem to find the distance between 2 points in a coordinate plane. You will learn more about this in Chapter 5. In a right triangle, the two sides that form the right angle are the legs. Make sure you have this definition down for legs. Two sides that form right angle. We're going to call those A and B. Go ahead and put A and B with the definition of legs. The other one is the hypotenuse. For hypotenuse definition, go ahead and write down the side opposite of the right angle. It's always the longest, and we're going to call that C. Okay, so go ahead and get a brief sketch of this diagram down. You don't have to have it in a coordinate plane, but make sure you match up this B. This is red is A, and this green is C. So this is the Pythagorean theorem. A squared plus B squared equals C squared. This is only applicable in a right triangle. Because this has the little box there, it tells us this is 90 degree. I can only use this when it's a 90 degree triangle. So the sum of the squares is going to equal the hypotenuse squared. That's what A squared plus B squared equals C squared. So I would take A, square that, add that to B squared, and that will equal C squared. Okay, this is the last example for this chapter. Example 4, finding distance in the coordinate plane. We're going to use the distance formula and the Pythagorean theorem to find the distance. Reduce the radical if necessary. So I'm going to bring this over here, make a little smaller. Notice our points D is 3, 4, and E is -2, -5. So the distance of DE, I'm going to use D as my point 2, E as my point 1 to show you that even if I chose the first point to be 2 and this point 1, I will still get the same answer. I'm going to go ahead and fill in my table. 3 minus negative 2 squared plus 4 minus negative 5 squared. This becomes 3 minus negative 2 is 5. 5 squared is 25. 4 minus negative 5 is 4 plus 5, which gives you 9. 9 squared is 81. This becomes square root of 106. This is not reducible by radicals, so we just leave it as square root of 6, square root of 106. So this is the distance, using the distance formula, of DE. Now we're going to use Pythagorean theorem to find what distance is. So notice here, they give you C, the longest side, opposite the right angle. This is a coordinate grid, so where they intersect at a grid point is a right angle. This is my B, this is my A. The benefit of using the Pythagorean theorem in the coordinate grid is I can count what B and A are. So I start here and I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. This distance is 9. I can do the same thing over here at A. 1, 2, 3, 4, 5. This distance is 5. So now what I'm going to do is put this in my Pythagorean theorem. A squared plus B squared equals C squared. A was 5, so I just plug in everything that I just found out. (25 plus 81 equals C squared. 106 equals C squared. But I don't want C squared, I want what C equals. So to find the C, I take the square root of C squared, and that cancels out the C squared. So C equals square root of 106. And that's the same thing that we found over here and over here. So using distance or Pythagorean theorem, you can find the distance. This one takes a little more counting. If you do this in your homework and you don't do it on graph paper, you run the risk of not making a perfect grid. On this one, you can definitely count out the grid spaces because of the nice, easy grid that they give you. When you do this on your own paper, you run the risk of messing up a little bit. So if you're going to use the Pythagorean theorem, use a nice grid paper. Take your time and draw a nice grid out so you can count those spots. You could very easily mess up and count this as 8 and this is 6, and you get a totally different answer. So make sure you're counting carefully and you're using the correct numbers.